This is my pre-algebra course. In the last class, we learned how to solve equations requiring 4 or more steps. Today we're going to learn how to solve equations with variables on both sides of the equation. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. You can see that we have variables on both sides of this equation. So what we have to do is we have to combine the variables so that all the variables are on either the left side of the equation or the right side of the equation. So as usual, we're going to rewrite the equation, and then we're going to subtract 3x from both sides of the equation. So that's the difference between this class and the previous class, is we're actually subtracting or adding variables to both sides. In the last classes, we only added or subtracted or multiplied or divided regular numbers with no letters. Now in this class, we're not going to multiply or divide by letters. That's you're going to learn how to do that in more advanced math courses. So we're just going to add or subtract variables in this class. All right, so these variables will cancel out, and you're left with 4 and negative 3x plus 7x is 4x. So then you want to rewrite. I should be using my colored pens here. I forgot to do that. I'm sorry. All right, so I get my green color out and divide by 4. And our final answer is x equals 1. And I'm going to try to be neater than I've been in the previous classes, so I'm going to try to not do this. I'm going to try to keep everything between the lines. All right, so on to number 2. We're going to rewrite the equation as usual. And I'd like you to try to keep things between the lines also. It just makes it neater. You can't always do that with this lined paper, but try to do that if you can. So what I'm going to do is I'm going to add 5y to both sides. Now I said that you can either put the x's on the left side or the right side. If we wanted to put the x's on the right side, it would require one more step in this particular example. But we could have put all the x's on the right side and then put that 4 on the left side. You can do that also. So in this case, I'm actually going to put the y's on the right side, whereas in the previous problem we put the we put the variable on the left side, the x on the left side. And the reason that I'm going to do that is I'm trying to avoid negative numbers. And you'll see why that is as we go along here. So I'm going to put 5y over here and 5y over here. So I'm adding 5y to both sides. And they end up with 3 is equal to 2 plus, and 5y plus 6y is 11y. So now all the letters are combined on the right side of the equation. All right, so now we have to rewrite that result. And now, because the letters are on the right side, they're combined on the right side, I have to put all the numbers on the other side. That's extremely important. Did you hear that? If you put the letters on the right side, then you have to put all the regular numbers on the left side, the other side. But which side, left or right, is not the important part. The important part is whatever side the letters are on, the regular numbers have to go on the other side. So if I put the letters on this side, then all the normal numbers would have to go on the other side. That's the most important part of this course. So if you didn't understand that, that's okay. We're going to do more problems. But let me get out my green color here. And we're going to put all the numbers on the left side. So in order to do that, I have to subtract 2 from both sides. And then these 2's cancel out, and I have 11y is equal to negative 2 plus 3 is 1. So do you see how I put all the regular numbers with no letters on the left side? I combined them. I combined them on the left side, and on the right side I have variables. So again, because I chose to put the letter on the right side of the equation, I had to put the normal numbers on the other side. All right, so now we're going to rewrite that step. And I'm going to get a different color here. I guess I can try to use purple. And the answer would be 1/11. All right, number 3. Now this problem is a little bit different because in this problem we don't have to rewrite the original equation. We don't have to rewrite all this. And the reason we don't have to rewrite it is because the first step requires simplification. And what that means is we're just going to combine terms on the same side of, or we're going to combine terms on the left side of the equation. And so we're going to write that result here. So there's no need to rewrite it at this point. So 7 minus 3 is 4. So I'm going to go ahead and write that. I can write it on the left side of the 3z, the negative 3z, or the right side. And then I'm just going to rewrite that expression on the left side. So now, all I did was I just simplified. If you can, you always want to simplify in the first step. Now, what a lot of students try to do is they try to say, "Oh, well, I'm just going to start. Adding 3 to both sides of the equation and subtracting 7. You're just going to do a lot more work than you have to. Whenever you have the opportunity to simplify in these equations, you always simplify first. Then you start adding and subtracting to both sides of the equation. So again, if you didn't understand quite what I meant by that, that's okay. We're only on the 3rd problem. We're going to do a lot of these problems before you try one on your own. So I want to stick with positive numbers if I can. So normally what I would do in this case is put all the z's on the left side, but I just want to show you what happens when you put the z's on the right side. We're going to get a negative number for the coefficient of the z's. It's not wrong, it's just a different way to do it. So I'm going to go ahead and rewrite that step. I want you to rewrite that step, and then I'm going to add 3z to both sides. And that's going to cancel out these z's, which is why I did that. And we're left with 4. Whoops, I'm getting messy. You see how I'm getting messy here? I'm trying to go too fast and I'm getting messy. All right, so, and then here's what I mean about the negative. We have negative 9z and positive 3z. So negative 9z plus 3z is negative 6z. So I ended up with a negative on the z. So it's students and mostly and I myself as well. We prefer to have a positive on that z term, but again, it really doesn't matter. You're still going to get the same answer. So in most cases, I would have put the z's on this side, and I would have ended up with a positive 6z on this side. But you can do it either way. So now we're going to rewrite that equation. Because remember, you always want to preserve, or at least in this class, you want to preserve the result of your calculations. We're going to subtract 6 from both sides. And I'm subtracting these 6's, has nothing to do with this 6. And we get negative 2 on the left side. And now I have to rewrite again. I want to preserve my work. And then I get my purple color here and divide both sides by negative 6. And our final answer is z is equal to positive 1/3. And we use the fundamental principle of fractions on that last problem. And again, a negative divided by negative is a positive. But I'm not going to keep saying that over and over again because by now you should know it. I don't want to bore students who already know that by saying it over and over and over and over again. All right, so let me move this over a little bit. Now we have a problem with fractions. So it works the same way that it does with the other problems. So I'm going to rewrite the equation as usual. And the reason that we're rewriting in this problem, and where we didn't have to rewrite in the other problem, is in the other problem the first step was simplification. So we just simplified in the first step. We didn't have to rewrite the equation. But in this problem, there is no simplification. We just have to go ahead and start moving stuff to other sides of the equation. So I rewrote, and I'm now going to let's see here. I'm going to subtract 3x over 4 from both sides because I know that will give me a positive coefficient on the x's, and I'm going to put a divider line. If your work starts to run into previous problems, then just put a divider line. That'll help. All right, so minus 3x, and so now on this side of the equation I'm left with 6, and now we have this math here that we have to do, so we're going to have to combine those fractions to get a common denominator. I'm going to multiply both sides of this fraction by 5 to get negative 15x over 20, and both sides of this fraction by 4 to get 8x over 20. And I'm not going to keep saying that over and over and over again. By now you should know the fundamental principle of fractions, so you should know how to combine fractions. You were already tested on that in this course, so I'm not going to keep saying that over and over and over again because I don't want to bore students. All right, and then minus 2. So let's see here. All right, so now we can combine the fractions, and we get negative 7x over 20. So now we're going to have to rewrite that equation to preserve our work. I'm trying to fit stuff between the lines here. And now we're going to add 2 to both sides. And it's very important that you keep that negative with this 7x over 20. And now we're going to rewrite that equation. Again, you need to keep rewriting all this stuff. I know it's tedious, but you have to do it to show your work. And we're going to multiply both sides by 20 as we did in the previous class. Be sure to write parentheses on both these terms so it doesn't look like subtraction. And you end up with negative 7x is equal to whatever 20 times 8 is, which is 160. So now I'm going to draw a line up here because we're running out of room, and I'm going to rewrite that. And then I'm going to have to get out a a different color pen here. I guess I can try orange. It's not going to show up very well, but whoops. I have to get a pen, not a highlighter. Sorry, I'm taking up your time here. Negative 7, divide both sides by negative 7. And x equals 160 over negative 7, and we're really pressed for room there, so I'm writing the negative in the denominator. All right, number 5. In number 5, like number 3, we have simplification in the first step. So the first step is to simplify 4x and 7x. We can combine those terms to get 11x. So I didn't have to rewrite the equation on the first step. And so do you want to put the x on the left side or the right side? It really doesn't matter. If you want to put the x's on the left side, you subtract 9 from both sides. If you want to put the x's on the right side, you subtract 11x from both sides. I want to stick with a positive because I know 11x minus 9x is going to be a positive, so that means that we're going to put all the x's on the left side because that's what I prefer. So subtract 9x. And 9x minus 11 is 2x. And then rewrite that result. And then we're going to add 3 to both sides as usual. This is just a two-step problem. And we did two-step problems many classes ago. So you have 2x is equal to 8. And then rewrite again. Again, I know the rewriting is tedious, but you just got to do it. You got to show your work. But we're not always going to have to do this rewriting. Once you get to more advanced math, you're going to be able to do a lot of this in your head. So we got 4 for number 5. That's going to number 6. Again, for number 6, we're going to have to simplify in the first step. So why don't you try number 6? Simplify those y's, combine them. And remember, you have to get the letters on one side of the equation and the regular numbers, the numbers without letters, on the other side of the equation. That's the most important thing. So try number 6, and when you come back, we'll do it together. All right, we're back. We're going to combine the negative 3y and the 6y to get 3y. And I just rewrite everything else. So again, just to make it clear, negative 3y plus 6y is 3y. So we just combine those y's on the left side of the equation. Now, if you want to get positive y's, you need to subtract y from both sides. I know that's strange to think about, but you're going to get used to that after a while. You're going to subtract y's from both sides, and that will make sure that we stick with a positive number. So we get 2, and negative y plus 3y on the left side is 2y. Then we get our green color, subtract 5 from both sides. It's just a two-step problem at this point. And we get negative 3 on the right side of the equation and 2y on the left side of the equation. And then I'm going to rewrite that. Again, you need to be rewriting all this stuff to show the result of your work. Divide both sides by 2, and we end up with negative 3/2. All right, let's go on to number 7. So number 7 looks like it's going to be pretty much the same thing with just minor differences. So try number 7, and when you come back, we'll do it together. All right, we're back. So the first step is going to be simplifying, combining these z's on the left side of the equation. So negative 6z minus 5z is negative 11z. And then just rewrite everything else. And so far, all the simplifying has been on the left side of the equation, but sometimes you have to simplify on the right side of the equation too, so just be aware of that. It's the same thing, it's just on the right side of the equation. So now, we want to stay with the positive numbers on the z's. So we're going to add 11z to both sides. And that will give us 4 is equal to 16z. And then we just have to rewrite that. And divide both sides by 16. And then we're going to have to reduce that fraction. Z is equal to 1 over 4. So if you got 1 over 4, good job. All right, so now we have a fraction problem. You have to get a common denominator and so on and so forth. Go ahead and try, let's see here. Yes, go ahead and try number 8. You know what, I'm just going to switch this around a little bit because we keep having the same problem where you simplify on the on the left side of the equation, but I just want you to know that sometimes we simplify on the right side of the equation. So go ahead and attempt number 8. It is a fraction problem, so it's going to be more difficult, but attempt number 8, and when you come back, we'll do it together. All right, we're back. So the first step is to simplify. We don't rewrite the equation. We simplify on the right side of the equation because we can combine the x's, the x terms, not the 1, but the x terms. So multiply both sides of the first fraction by 4, and you get 4x over 8. So now I have common denominators on everything. So then we can add these two fractions. 4x over 8 minus 3x over 8 is x over 8. So that was a big step there. We combined all those 8's. And now I need to go ahead and rewrite this because I'm about to perform an operation on both sides of the equation. Always rewrite when you perform an operation on both sides of the equation. And I want to stick with positives, so I'm going to add positive x over 8 to both sides. So then I end up with 2x over 8 on the right side, and just rewrite the 1. And these cancel out, which is why I did that. And I'm left with 5 on the left side, and we're about to perform an operation on both sides of the equation, so we have to rewrite. But when I rewrite, I'm going to simplify this fraction to x over 4. So again, that's just the fundamental principle of fractions. 2 divided by 2 is 1, 8 divided by 2 is 4. So now I'm going to perform an operation on both sides of the equation again, so I have to rewrite and subtract 1 from both sides of the equation. X over 4 is 4. So now, I'm going to perform an operation on both sides of the equation, so I have to rewrite. I need to get my purple pen out, and this is x divided by 4. Why do I know it's divided by 4? Because the fraction sign in algebra means division. So x divided by 4, I have to do the opposite of division to get rid of that 4, and the opposite of division is multiplication, and we show multiplication with parentheses. So now I'm out of room, so one thing I can do, if I have a digital notebook and OneNote, is I can shrink some of this stuff, and that'll give us enough room for the last step. So the 4's cancel out on the right side of the equation. So you're left with x, and 4 times 4 is 16. So if you got 16, that's a really good sign. That means you're getting this stuff. If you didn't get 16, that's okay. That was a long problem, and there's a lot of steps. So if you made a mistake, don't worry. Just go back and figure out what you did wrong. So here's another problem where we're simplifying on the left side of the equation. I have too many of those problems. Let's do one where we simplify on the right side of the equation. So go ahead and try number 9, and when you come back, we'll do it together. All right, we're back. So we're going to begin by simplifying on the right side of the equation. Negative y plus 2y is just y. So again, I just combined the negative y and the 2y. Remember, if you have a negative in front of the y, that's assumed to be negative 1. A lot of students would just consider this to be 0, and they would pretend that it's not there, and they would just combine these y's to make it 2y instead of 1y. And again, here I want a 1y, so I just put y instead of 1y. We explained that in the previous classes. All right, so now I'm about to perform an operation on both sides of the equation, so I go ahead and rewrite, and I want the y's to remain positive, so I'm going to subtract y from both sides. But again, if you get a negative on the y, that's okay. It's not wrong. It's just whenever you deal with negatives, it's one more thing that you have to worry about. And we end up with 4 is equal to negative y plus 3y is 2y. So now I'm about to perform an operation on both sides of the equation again, so I have to rewrite that. And I'm going to get rid of, because my letters are on this side of the equation, I have to have all the regular numbers on the other side of the equation. That's the most important thing to learn today. So I have to add 1 on both sides. And you get 2y is equal to 5. So if you run into the situation, because a lot of students, what they're going to do is they're going to try to subtract 4 from both sides. Whoops, they're going to try to subtract 4 from both sides. And what's going to happen is oftentimes students are going to put both the letters and the regular numbers on the same side, and on the other side there's going to be 0. You don't want to do that. If you did that, if you put everything on one side of the equation and there's nothing on the other side, that means that you did something wrong. So anyway, we're left with 2y is equal to 5. I'm about to perform an operation on both sides of the equation, so I have to rewrite that. And divide both sides by 2, and our final answer should be 5 over 2. So if you got 5 over 2, good job. But again, these problems are very challenging. There's a lot of steps. So if you make a mistake, do not be frustrated. It is perfectly normal to make mistakes. That's the purpose of this course, is to teach you fluency, and the only way you can learn is by making mistakes and then correcting those mistakes. All right, so in number 10, there's no simplification that we can do in the first step, at least as far as one or the other side of the equation. One side or the other side. So we just have to go ahead and rewrite the equation in the first step. So now we want to get all the z's on either the right side or the left side. Now I know that if I add 8z, if you add 8z to both sides, then all the z's are going to end up on this side, and it's going to be positive because 8z plus negative 3z is 5z. But if I add 3z to both sides, to get rid of this z, so our z's will end up on the right side, then it'll be positive 3z, or 3z plus negative 8z is negative 5z, so I'll get negative 5z. So again, I prefer to have positives on the variables. So I'm going to add 8z to both sides. And we have 2, and 8z minus 3z is 5z. And now we have reduced it to a two-step equation. So I'm about to perform an operation on both sides of the equation. So I have to rewrite. I'm going to subtract 1 from both sides. And we end up with 5z is equal to 1. So now, again, I'm about to perform an operation on both sides of the equation, so I have to rewrite it and divide by 5, and our final answer is 1 over 5. So if you got 1 over 5, that's a good sign. That means you're doing it, you're learning fluency in algebra. If you didn't get 1 over 5, then just go back and figure out what you did wrong. So now let's go back to one of the easier problems. If you're having trouble with those long ones, let's get to an easier one here. So go ahead and attempt number 11, and when you come back, we'll do it together. All right, we're back. So in this problem, we couldn't really simplify in the first step. So we're just going to go ahead and perform an operation on both sides of the equation, which means we have to rewrite the equation. And I'm going to subtract 9x from both sides. That's the easiest way to do it. And I get negative 3 is equal to 2x minus 9x is negative 7x. So this one's going to be kind of a short one. I'm about to perform an operation on both sides of the equation, so I have to rewrite the equation and divide both sides by negative 7. And we have x is equal to 3/7. because a negative divided by a negative is a positive. So if you got 3/7, that's really good. Good job. All right, so this is definitely going to be a more difficult one. This is the first problem, I believe, where we have to simplify on both sides of the equations in the first step. So let's do this one together. Negative 8z minus 4z is negative 12z, so we simplified that. We combine those z's on the right side of the equation. And now we have to combine the z's on the left side of the equation. Now we have to combine the z's on the right side of the equation. So 3z minus 6z is negative 3z. And now it reduces to a problem where we're just going to start performing operations on both sides of the equation. So we have to go ahead and rewrite. So we simplified the expressions on both sides of the equation, but we still haven't combined the letters on one side of the equation. We have to get all the letters on the same side of the equation. So if I add 3z to both sides to get rid of the z's on this side, then we're going to end up with a negative on the left side. So I'd rather add 12z to both sides, and then we're going to end up with positive z's on the right side. So I get out my red pen, add 12z to both sides, and I'm going to have to move that over. It's okay if you move over your equations a little bit. Just try to keep that equal sign relatively lined up. So add 12z to both sides. And that's a little too sloppy for my taste, so I'm going to have to move this over a little bit more. Sorry, I'm taking up your time here. Plus 12z. Your work has to be good enough to where somebody can go back and easily read it. Okay? It has to be read easily by somebody else who doesn't know your handwriting. All right, so 8 and negative 3z plus 12z is 9z. Make sure you put in positive 9z. So as you can see, things are getting a lot simpler. We're down to a two-step problem. So now we're going to add 1 to both sides. And we have 9z is equal to 9. We're about to perform an operation on both sides of the equation, so we rewrite. And then we're going to divide both sides by 9. And we get z is equal to 1. So we'll do another problem like that together where you have to simplify on both sides of the equation in this next problem. So the next problem, we only have to simplify on one side of the equation, so I'm just going to add a negative 7 here. And now we're going to have to simplify on both sides of the equation. Actually, you know what? I'm going to add a negative 7y. There we go. So we have y's to combine on the right side of the equation, and we have just normal numbers to combine. Well, let me make that clear. So we can combine these y's on the right side of the equation, and we can combine the regular numbers on the left side of the equation, and we can do that all in one step. So that's the first step. We're not going to rewrite the exact equation. So if we combine, we have negative 1 plus 5 is 4, and then 4 plus 2 is 6. So we have 6, and then we just rewrite the negative 7y. All right, I'm gonna be as neat as I can here. Now we're going to add the 5y and the negative 7y to get negative 2y. And then just add your 6 there, and you could switch these around. You could write 6 minus 2y also. It doesn't really matter, whichever way you prefer. So now we're ready to put all the y's on the same side of the equation. So in order to do that, we have to perform an operation on both sides of the equation. So I have to rewrite. Whoops, why did I write a negative 6 there? All right, so now we're going to have positive coefficients. We have to add 7y to both sides. And we're left with 6. And then negative 2y plus 7y is 5y. So we're about to perform an operation on both sides of the equation. Rewrite. And we're going to subtract 6 from both sides of the equation. And we're going to be left with 0. So now we're going to rewrite. And we're going to divide both sides by 5. And you tell me, if you have a fraction with 0 in the numerator, what is that value going to be? Well, if you said 0, good job. So I forget if I had you do that one on your own, but if you did that one on your own and you got 0, good job. All right. So number 14. I'd like to do another problem like that where you have to simplify on both sides of the equation, so I'm going to add a 3z here. So you're going to have to simplify on both sides of the equation. Try number 14, and when you come back, we'll do it together. All right, we're back. So negative 9z plus 3z is negative 6z, and 1z plus 3z is 4z. Yes, that is a 1z, even though there's no 1 there. So, so all we did was just simplify. Now we're about to perform operations on both sides of the equation. So now, and this is kind of an interesting situation, because in this problem, if we want to get a positive coefficient on the z's, remember the coefficient is just the number that is next to the z, next to the letter. That's just what they call that number, a coefficient. If we want to get positive numbers, we're going to have to add 6 to both sides. But if we do that, everything is going to be on the right side. So then we're going to have to add 1 to both sides. So we're going to have to do 2 steps. But if we subtract 4z from both sides to get a negative on the other side, then we only have to do 1 step. So this is a case where it's actually better to just get a negative coefficient. So you'll see what I mean. Whoops. I'm rewriting the same thing again. So we're going to subtract 4z from both sides. And I'm going to have to move this stuff over a little bit. So we're subtracting 4z from both sides. And you can put a divider line here. Negative 4z minus 6z is negative 10z. All right. So now we're going to divide by negative 10. And this problem is going to be over pretty quickly here. That wasn't a long problem. Z is equal to 1/10. So if you got 1/10, that means you're on the right track. If you didn't get 1/10, that's okay. As long as you're concentrating on what you're doing and seeing where you're making the mistake, you're going to be fine, because we're going to do more of these problems. So at number 15, you're going to have to simplify both sides of the equation first. Then you're going to start performing operations on both sides of the equation. So try number 15. And when you come back, we'll do it together. All right, we're back. Negative 8 plus 1 is negative 7. And 7x minus 1x is 6x. I'm going to subtract 5x from both sides. I'm going to subtract 3. And negative 3 minus 7 is negative 10. So if you got negative 10, that's very good. You're starting to become an algebraic master. All right, I'm going to go ahead and put a divider down here. So now we have a problem with fractions. So you can do this one with me, or you can try it on your own. It's really just the same type of a situation that we had in the last class when it comes to the very end of the problem. So go ahead and attempt number 16, and when you come back, we'll do it together. All right, we're back. It looks like we can simplify the left side of the equation. So I'm going to get a common denominator, multiply both sides of this fraction by 2. So that's all we've done so far, is just get a common denominator. So now I can combine these fractions. Negative y minus 4y is negative 5y over 6, and plus 4 or equals 4, blah, 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 blah. You get the point. All right. So now we're ready to get the y's on the same side. And 5y over 6 plus 5y over 6 is 10y over 6. And the y's on the left side cancel out. And we can reduce this to 5y over 3. And now we're about to perform another operation, so we gotta rewrite that equation. Subtract 4 from both sides. And again, there's multiple ways to do this, so you may not have done it exactly the same way I did it. Just because you're not doing it exactly the same way doesn't mean that your answer is wrong. So don't lose hope. So now we have to rewrite, because we're about to perform an operation. Now this is where you have to think back to the previous class. We have to get rid of the 5 and the 3, so we're going to need 2 more steps. Now there is a way to do it faster, but I don't want to confuse you, so I'm gonna avoid that method. There's always ways to do things faster, but when you're trying to learn the language of algebra, faster methods often just confuse students. So 3 times 5 is 15, the 3's cancel out, and now I'm going to put an arrow up here, and I'm going to rewrite that because we have one more step. Divide both sides by 5, and our final answer is 3. So if you got y equals 3, I'm impressed, because the problems with fractions are particularly difficult. All right, on to number 17. Do number 17, and when you come back, we'll try it together. All right, we're back. 12x minus 15x is negative 3x. Eight x plus 2x is 10x. Then be sure to rewrite that result, because we're about to perform an operation on both sides. And I'm going to add 3x to both sides. And we're about to perform another operation. So rewrite. Subtract 3x from both sides. And rewrite again. Divide both sides by 13. And x equals 7 over 13. So if you got 7 over 13, very good. All right. Try number 18, and when you come back, we'll do it together. All right, we're back. The first step is going to be simplifying the right side of the equation. Then rewrite that result. Add 5y to both sides. Now we need to put a divider here. Rewrite the result of that step. Divide both sides by -2. And if you got y equals -7 over 2, good job. All right, on to number 19. We've got fractions on number 19. So these fraction problems are particularly difficult, but why don't you go ahead and try 19, and when you come back, we'll do it together. All right, we're back. So we can go ahead and combine these y's. Whoops. We can combine the y's because they already have a common denominator. 3y over 5 minus 2y over 5 is 1y over 5. But notice I didn't put 1y, I just put y here. Whoops, I need to remember not to get sloppy here. And we can just rewrite everything else. I'm about to perform an operation on both sides of the equation. So I rewrite, and I'm going to add y over 10 to both sides of the equation. And now we have to get a common denominator. So I changed the form of this fraction to 2y over 10. So now we can combine the y's. We can finally combine those y's. 1y plus 2y is 3y. And let's see here. Now we're ready to get the numbers on the other side. Because our letters are all on this side, we have to get the numbers on the other side. So subtract 1 from both sides. We have 3y over 10. Now I'm about to perform an operation on both sides, so we got to rewrite that. And I want to get rid of the 10 first. So that's divided by 10, so we have to multiply, whoops, we have to multiply by 10 to get rid of it, because multiplication is the opposite of division. And 10 times 3 is 30. The 10's cancel out, you end up with 3y. Now I'm going to perform an operation on both sides of the equation again. So I need to rewrite that. And now I need to get a different color here. Divide both sides by 3. And our final answer, if you put an arrow up here, our final answer is going to be y is equal to 10 over 3. So if you got 10 over 3, good job. All right, we're going to go back to an easier one here. Not all of these problems are going to be so many steps. So attempt number 20, when you come back, we'll do it together. All right, we're back. 7x minus 10x is negative 3x. And now we just have to get all the x's on the same side. So what I'm going to do is put all the x's on the right side, which means I have to perform an operation on both sides of the equation. So I have to rewrite the equation, and I'm going to add 3x to both sides. And that's an unusual problem, because at that point, because we have a coefficient of 1 on the x, and because all the numbers canceled out, that's our answer, x equals 1. So that was a short problem. On to 21. Attempt number 21, and when you come back, we'll do it together. All right, we're back. Negative 2x plus 4x is 2x. And x minus 9x is negative 8x. Now I'm about to perform an operation on both sides of the equation, so I have to rewrite. And I'm going to subtract 2x from both sides of the equation. Even though that's going to give me a negative, I still want to do it that way because it's going to require less steps. So now we get negative 10x on the right side if you simplify this, and 6, rewrite. Divide both sides by negative 10. And our final answer is going to be negative 6 over 10, but we can reduce that to negative 3 over 5. So if you got negative 3 over 5, good job. Try number 22, and when you come back, we'll do it together. All right, we're back. Negative 3y plus 2y is negative 1y. But we don't write the negative 1, we just write negative y. Why? Because that's just tradition. All right. Now I'm going to add y to both sides of the equation, so I have to rewrite the equation. So I'm going to add y to both sides. So it looks like this is going to be another short one. Divide both sides by 11. And we have negative 4 over 11 is equal to y. So if you got negative 4 over 11, good job. Try number 23, and when you come back, we'll do it together. All right, we're back. 8x plus 2x is 10x. And I'm going to write the negative 4 on the other side just to show you that it can be done. I could write it like that also. I haven't been doing that, but that's completely legal. Just to show you that it can be done. So at that point, I'm going to perform an operation on both sides of the equation. So I have to rewrite, and then I'm going to subtract 9x from both sides of the equation. Whoops. I usually start with red. Negative 9x plus 10x is x. And then I'm going to have to perform an operation on both sides of the equation, so rewrite as usual. I know you're getting sick of me saying that, but it's so important. I got to keep reminding you, you got to show your work. If you don't show your work, it's a waste of time. And it looks like we got 0. So if your answer was 0, that's very good. Try 24, and when you come back, we'll do it together. All right, we're back. So on the first step, we can simplify the right side of the equation by adding or combining the 3 and the 5. So 3 minus 5 is -2. Then we're going to perform an operation on both sides of the equation because we've already simplified everything on each side of the equation. So we have to rewrite. Now I'm going to subtract 6y or 6y from both sides. Make a divider here. And that's going to give us 7y minus 6y is y. And negative 6y plus 6y is 0. So you're left with -2. I'm about to perform an operation on both sides of the equation, so I have to rewrite. And I'm going to add 2 to both sides. Again, if all the variables and all the numbers end up on the same side, then you did something wrong. And I got 0 again. So it looks like that was another 0 problem. So if you got 0, good job. All right, I think we have 4 more of these problems. If you've made it this far, I'm proud of you. Good job. So now try number 25, and when you come back, we'll do it together. All right, we're back. 9x or minus 10x is -x. That's the first step, is to simplify the left side of the equation. Now everything is simplified on both sides of the equation. So we can go ahead and add x to both sides. (8x plus 1x is 9x. Then we're going to subtract 3 from both sides. And -3 plus 1 is -2. And we're about to perform an operation, so we have to rewrite and divide both sides by 9 because we want to get x by itself. Remember, that's what we learned in the previous classes. We're trying to isolate x. So if you got -2/9, good job. Try number 26. And when you come back, we'll do it together. You can put dividers here if your work is starting to get cramped. Try 26, and when you come back, we'll do it together. All right, we're back. -y plus 2y is y. So it looks like this is going to be another easy one. And we cannot simplify the right side of the equation. So both sides of the equation are simplified now. So we're going to have to perform an operation on both sides of the equation, rewrite. And the easiest way is to subtract y from both sides. And we get -2, and then these combine, these -3y minus y is -4y. Rewrite again. And I'm going to add 2 to both sides. I'm going to get 6 over here, and -4y. Now it's very important you take the negative with the 4y. Bring the negative with the 4y. If you got this problem wrong, I would assume that's probably where you, it's a good chance that's where you made a mistake. It's one of the most common mistakes that students make in algebra. Divide by -4. And we have y is equal to -3/2 using the fundamental principle of fractions. Divide both sides of the fraction by 2. So if you got -3/2, good job. Alright, so for number 27, you can simplify both sides of the equation in the first step. So go ahead and try 27, and when you come back, we'll do it together. Alright, we're back. 10x minus 11x is -x. And -7x minus 4x is -11x. And looks like we can simplify something else. We can simplify 8 and the 1. We can add those up and we get 9. So in that problem we had a lot to simplify. We had to simplify x's on this side, x's on this side, and regular numbers on this side. So sometimes you have to do quite a bit of simplification. Alright, let me just double check that, make sure it's correct. Looks correct. And by the way, I can write this as 9 minus 11x, and the other side is 2 minus x. There's different ways to write it. So if you want to write it in those other forms, that's fine. So I'm ready to perform an operation on both sides of the equation, so I must rewrite the equation. And I'm going to add x to both sides. And I'm going to perform another operation on both sides of the equation, so I have to rewrite. Subtract 9. And I'm going to rewrite the equation again because I'm about to perform an operation on both sides. And finally, x is equal to 7/10. So if you got 7/10, good job. You can also write 7/10 as 0.7, but we don't really need to do that. Alright, so try number 28, and when you come back, we'll do it together. Alright, we're back. 6y minus 8y is -2y. And 3y plus 5y is 8y. And we're done simplifying both sides of the equation. So we're going to go ahead and rewrite because we're about to perform an operation on both sides of the equation. And I'm going to need to move this over a little bit. Subtract 8y from both sides of the equation. Put your divider. -8y minus 2y is -10y. So rewrite that because we're about to perform the last operation. Divide both sides by -10. Seems like we're dividing by -10 a lot in these problems. And we get -2/5. So if you got -2/5, good job. So that was the last problem of the day. So we did a lot. As you can see, it's the same type of math. The most difficult thing in this course is adding and subtracting negative numbers and combining terms with positives and negative signs. This is all the work that we did today. If you want to take screenshots of these pages so that you can use them to help you with your homework or study for tests, go ahead and do that now. So now we're ready to look at the homework. So this is the homework. Take a screenshot of that. And remember, you must do the homework completely and correctly and show all work just like I showed the work. Rewrite the step before you're going to perform an operation on both sides of the equation. Write your original problem, rectangle your answer, do all those things that I have been doing in my previous course and this course. And put your name, the date, the course, just as you see here. Put a title. These are all things that you have to do in a real course. And this is a real course, so you must do those things. And the most important thing is that you check all of your answers. If you do the problem and then you don't check your answer, that means that you don't really care if you did the problem correctly, and you may make all kinds of errors and you're not going to learn anything. You only learn something when you make a mistake and then realize what the mistake was. That's the learning process. If you don't check your answers, that's never going to happen, and you're going to learn zero. So get all that homework done, and I'll look forward to seeing you in the next class.